Welcome to one more episode of Test Master. In this video, we are going to see what is dB and dBm. For students, these are very confusing terms, and this video will help them to accelerate the learning of these topics. It is a logarithmic way of defining a ratio. It is used to measure sound, pressure, voltage, power, etc. So usually when we calculate large values with small, it is often difficult because of lot of zeros before and after the decimal points. For example, a mobile tower, which is transmitting in kilowatts, is having a lot of zeros after the decimal point, before decimal point, and a mobile receiver, which is receiving in nanowatts, is having lots of zeros after the decimal point. So when we do a calculation of path loss or something, so it is very difficult to uh, express. So in order to avoid these problems, these difficulties, we are using the terms dB and dBm. Basically, the units of RF power traveling down the transmission line are specified in watts, and we often find ourselves difficult in comparing two power levels which that greatly differ. For example, the output of a transmitter might be 2 kilowatts, while the signal level at the receiver's antenna might be in picowatts. Dealing with such large differences usually using a linear scale is awkward, so a logarithmic or decibel scale is normally used when expressing power. Now things are more difficult to explain with watts. RF systems operates power much less or greater than 1 milliwatts. High power transmitters operate at 1 megawatts, while a mobile phone receives below 1 nanowatt. All of the zeros before the decimal point for high powers or after the decimal points for low powers make calculation cumbersome. To solve this problem, the dB and dBm system of units is used. So we will see how to convert to dB. So it is 10 log P1 by P2. So we have two power levels. Suppose we have two power levels. One is of a nanowatt, 1 nanowatt, and the other power level, which is P2, is of 1 megawatt. Since it is difficult to compare or subtract these values in order to calculate a loss or gain, we use the dB terminology. So when we calculate in dB, it is 10 log P1 we are taking as the nanowatt, and P2 is the transmitter's power, that is in 1 megawatt. So the difference we can express as minus 150 dB. So that can be the loss, path loss from transmitter to the receiver. The dB terminology is used for the ratio between two power levels. Now we will see what is dBm. The dB number systems can also be used to express absolute values of RF power as dB relative to 1 milliwatt. So 1 dBm equal to 1 milliwatt. At RF frequency, the reference power is defined as 1 milliwatt, that is 1 by 1000 watt. 1 milliwatt is just enough to operate a telephone, video display, or computer. So the standard power reference level in the telecom industry is 1 milliwatt. So now we will see how to convert from watts to dBm. So dBm equal to 10 log P by 1 milliwatt. Here 1 milliwatt is reference and P is the power which we want to convert to dBm. For example, if P1 is 1 nanowatt, then we will get minus 60 dBm, and if P2 is 1 megawatt, and we get plus 90 dBm. This makes the calculation easy to compare. So if we know the transmitter power is 90 dBm and receiver power is minus 60 dBm. Then we can calculate minus 60 minus 90, it is minus 150 dB. So here are some quick calculations how to find the values of, how to convert from dBm to milliwatts. These are some shortcuts. So 0 dBm is the standard reference, which is equal to 1 milliwatt, and when for every 3 dBm the watt doubles. So at 3 dBm it is 1.995, it is approximately 2 milliwatt. At 6 dBm it is 3.981, which is 4 milliwatt, and 10 dBm it is 10 milliwatt. For every 10 dBm increase, the watts multiply by 10. So 10 dBm is 10 milliwatt, 20 dBm is 100 milliwatt, 30 dBm is 1 watt, 40 dBm is 10 watt. Like that it multiplies. And this page is the arithmetic, how we can add and subtract dBm. 0 dBm plus 0 dBm, it is, we cannot directly calculate 0 dBm plus 0 dBm. Instead of that we have to convert to milliwatt or watts, and we have to calculate. So 1 milliwatt plus 1 milliwatt equal to 2 milliwatt, which is equal to 3.01 dBm. 0 dBm plus 3 dBm equal to 1 milliwatt plus 1.995 milliwatt, which is equal to 2.995 milliwatt, which is 4.76 dBm. Minus 10 dBm plus 10 dBm, which is equal to zero point 0.1 milliwatt plus 10 milliwatt equal to 10.1 milliwatt equal to 10.043 dBm. Thank you for viewing this video. Please add your comments below. Thank you.